Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are ringing in Arithmetic Sequences by the legendary rock band The Cars and their mega hit, Let's Go, one of my faves. And let's get right to it, shall we? We are talking about Arithmetic Sequences, Part 1. We will check back in with the Cars towards the end of the video. So what is an arithmetic sequence? Well, it's a sequence in which each term differs from the previous one by the same fixed number. And it can also be referred to as an arithmetic progression. That means that you add the same thing to a term to get the next term. You do that over and over and over again. That's the easy way to think about it. But we need to define it as a difference so that we're able to prove and know that it is indeed an arithmetic sequence. For example, the sequence 2, 5, 8, 11, and 14 is arithmetic because 5 minus 2 is 3. 8 minus 5 is 3, 11 minus 8 is 3, and 14 minus 11 is 3. All of those are equivalent. Just like 27 minus 31 is equal to 23 minus 27 is equal to 19 minus 23. All of those are equal to negative 5. Okay. Oh wait! No! Negative 4. I'm such a loser. But you know that. So, the algebraic definition of an arithmetic sequence is u sub n plus 1 minus u sub n equals d for all positive integers n. And we'll talk about that in a second. And d is very important. It's called the common difference. It's called the common difference. Okay. And where does that come from? Where does arithmetic sequence come from? It comes because the middle term of any three consecutive terms of an arithmetic sequence is the arithmetic mean of it. And the formula we can use to find the nth term of an arithmetic sequence is right here. It is u sub n equals u sub 1 plus n minus 1 multiplied by d. d is the common difference. Now, n is always going to be, it must be, a positive integer. So that would be 1, 2, 3, 4, 5, and so on. Must be one of those numbers. It cannot be a decimal or a fraction or anything like that. So if this, for example, if n were equal to 5, we're talking about the fifth term, u sub 5. So this n would be 5, and this n would be 5. It's the same n. So u sub 1 is the first term in the sequence, and d is the common difference. Okay, so here we go. So let us consider the sequence 2, 9, 16, 23, and 30. Okay, so the first thing that they're asking us to do is show that it is indeed an arithmetic sequence. And the only way to do that is to show that the common difference between consecutive terms is the same. It is constant. So it would be term minus previous term. 9 minus 2 equals 7. 16 minus 9 equals 7. So all the terms that they give us, we're going to do this for. 23 minus 16 equals 7. And 30 minus 23 is equal to 7. So we have, given the information that we have shown that this sequence is indeed an arithmetic sequence just by doing this. Now, this is called, this difference, 7, these 7s are called the common difference. Well, that makes sense because they're all the same, so they're common to one another. And it's a difference because you subtract term minus previous term to get it. And we represent that with a lowercase d. Find a formula for the general term u sub n. Okay? Well, the general term is found using this formula. I'm going to rewrite it here. U sub n equals u sub 1 plus n minus 1 times d. So all we need for the general term is the first term and the common difference, the first term of the sequence. Okay, so u sub n is going to equal, the first term in this sequence is 2, right? So that would be 2 plus n minus 1, and then I just need the common difference d, which we already know to be 7. And then I can simplify that. Okay, so my final term, well, not yet. Let's just simplify that. I don't have to, but it's just going to make my life so much easier when I answer questions C and D. So this would be 2 plus 7 times n is 7n, and 7 multiplied by negative 1 is negative 7. So my general term turns out to be 7n, and then 2 minus 7 combined is a minus 5. So that's my general term. I can use this to find any term in the sequence. And in fact, they asked me to find the 100th term. The 100th term, right? So that means that n is going to equal 100 if I'm going to find the 100th term. So I'm going to use my general term right here. I'm going to rewrite it. U sub n equals 7n minus 5. Okay, and I'm looking for the 100th term. So u sub 100 is equal to 7 times 100 minus 5, which is 700 minus 5, which is 695. That means if I just kept adding 7, right? First term, second term, third term, fourth term, fifth term, and I kept adding 7 all the way to the 100th term, it would be 695. And finally, the last question we'll answer for this video, part 1, is 828 a term of the sequence, and also 2341. So this is DI. Well, if it's true, oh, this is handy, my formula right here. If this is true, then n would have to be an integer, because remember, n is a positive integer. So we're going to see if some term in the sequence is 828. If that's true, then u sub something is going to equal 7n minus 5, right? So I'm looking for that n. So I'm going to let this term be 828. So 828, going to set that equal to 7n minus 5. Now I can solve this equation easily. I'm going to add 5 to both sides, and that becomes 833 equals 7n, right? Now here comes the big part. When I divide that by 7, is it an integer? So I'm going to go to my handy dandy calculator, and I'm going to take 833 and I'm going to divide it by 7, and I get 119. Nice! Nice, nice, nice. So that means since 119 is an integer doesn't have, it's not, it doesn't have point something, it's not a fraction, then the answer is clearly, it's the 119th term in this sequence. In other words, if I listed 119 terms, this 828 would be the 119th term. So the answer is yes. Okay, and then we'll try the same thing for 2341. Okay, so now we'll solve this equation. 2341, replacing u sub n with it, equals 7n minus 5. Okay, we'll add 5 and we get 2346 equal to 7n, and we divide both sides by 7. And so we get n is equal to, so now I have to do 2346 divided by 7. Bam! Uh-oh! 335.1 will round to the nearest tenth. So n equals 335.1. Okay? So if you're counting terms, you're counting using integers. There's no such thing as the 335th.1 term. There's a 335th term and a 336th term, but there's no 0.1 term. So that means that this is not a term in this sequence. No, 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 no. So that's how you understand that. All right, so hopefully you enjoyed that. I know I did. We will sign out with the great legendary Cars Band, and we'll move on to part 2. For the time being, I am out!